Okay, so in our notes, we are in the, I think the 212s. And we're actually ready for example 3, but I want to hold off on 3 and 4 and do example 5 first because that's review from yesterday. So that'll get us caught up, back up to speed in case we forgot something in the last 24 hours. So example 5, we're going to come back and do 3 and 4 in a second. But example 5 says, which of the following is the same as 3 ln x minus 4 ln y? Now, we aren't confused by that at all because ln is simply another version of logarithms. So whatever we talked about yesterday with log applies to ln. It's just a different base. So, what did we do yesterday? Our job is to write this as a single expression. So, what does that subtraction tell me? It's going to be a division. So I'm going to have x's on top of y's. And then what about the 3 and the 4? What are they? They are exponents, the 3 on the x and the 4 on the y. So the answer is what, A? Easy. Okay, now let's hop back up to example 3. We have the log of 6x. Now notice that the coefficient is on the x. So how does that impact our graph? What does a coefficient on x do to our graph? It stretches or shrinks it horizontally, right? So what these directions are saying, okay, you've got a horizontal dilation right here. Rewrite the problem so that you have a vertical translation. That sounds so hard, but it is so easy. The fact that these are multiplied means that when I split them apart, it will be an addition. Will you agree with that? Now, this is the same function, whatever it was called, f. This is exactly the same function. I just broke it apart. And now, it's the basic logarithm function plus something. Well, what does plus something do to your picture? Picks it up. This one would go up. So this was a horizontal dilation, a stretch or shrink horizontally, and this is a vertical translation. Picked it up. Now, log 6 is just a number. So I'm not sure if we're supposed to leave this as log 6 or if we're supposed to figure out what that is. But do you see what's happening, guys? See how easy that is? Now you're taking this thing and lifting it up 0.778. Well, I think that's kind of cool. Okay, let's look at example 4. We have a similar thing happening in example 4. We have two functions, two basic logarithmic functions, but they have different bases. What we learned yesterday, what does that difference in basis mean in terms of the graphs? Remember that picture we looked at? It had 3 logarithmic curves, and they were all going through the same point, but one was kind of flat, and one was in the middle, and one was going up faster, and that was all base deal, right? Based on the base. So that's what's happening here. We have 2 different logarithmic functions. Show that f, oh wait, no, not a problem. Show that f is a vertical dilation of g by finding the value of k. Now, again, don't let all the words blow your mind. When we have a regular old function, when you put a coefficient on the x, that is a horizontal dilation. When you put a coefficient on the function, on f, that becomes a vertical dilation. When you add or subtract on the end of the problem, that is a vertical translation. And when you add or subtract in here, it's a horizontal translation. Okay, so don't get confused by the words. They're asking you to show that f, function f, is something times, some number, times g. So your job is to find that number. Okay. So let's back up a second. I don't know if it was yesterday or the day before, I can't remember, but we had the log base 4 of, I use a different number, the log base 3 of 7, and I told you that we can always real easily rewrite that, so I can type it in on my calculator. Even remember how we did that? How did we rewrite that? Kennedy? Well, that would be how we would rewrite it if we were writing it in exponential form. That's 100% accurate. And I can get where I'm going from there. But there's kind of a shortcut. But Kennedy, that isn't wrong. You can get there from that. Raina?
You can do log 7 divided by
Exactly. So you can make this log 7 divided by log 3. If you want that, if you want to know what that equals. Now, I think at the same time we talked about, I hope, that it doesn't have to be LOG. It could be LN7 over LN3. Either one of those would be perfect for my calculator because those are the two buttons I have. Right? Right, now wait a second. Let's look at this right here. Can that be rewritten? Actually, you know, I want to look at this one. Can this be rewritten? I'm gonna catch my breath. I gotta rewrite one of them. Well, I'm just gonna pick one and see if it's the right one. So I'm gonna rewrite this, okay? And when I rewrite this, if I use those tricks over there, it would be log x over log 4. Agreed? That base is 10. What if I wanted the base to be 9? Now, I would never do that in real life because I don't have base 9 on my calculator. But for purposes of this problem, couldn't I say this is log base 9 of x over log base 9 of 4? Guys, we did it with base 10. We did it with base e. We can do it with base 9. So basically, f of x, this was f of x, can be written, I don't need this, can be written as the log base 9 of x over the log base 9 of 4. In other words, f of x is 1 over the log base 9 of 4 times the log base 9 of x. Just separating this fraction. Now, what's the log base 9 of x? Isn't that g? So this says 1 over the log base 9 of 4 times g of x. Well, shoot, isn't that what I was supposed to do? So what's k? K is this number right here. Is this a number? Can I figure out what that number is if I actually want a decimal for it? How would I figure out this number?
4
no, you're right, go
Just
ahead,
that same
let's
way.
do that, I know.
Log 4 divided by log 9.
Log 4 divided by log 9,
Then you get a number and then over 1.
reciprocal. Yep, so basically, I don't want anybody to get confused, but since this is 1 over, could I just type into my calculator log 9 over log 4? To get this coefficient right here? Or, you can type it in regular, and then find the reciprocal of it. Okay, so let's do that, what is that? What is that coefficient gonna be?
Excuse the interruption.
Yeah.
Could you please send Anna Moore to Student Services at the very end of the period?
Yep.
Thank you.
Okay, Anna, the very end of the period. What did I type in? All right, I got 1.585, I think, times g of x. Anybody else get that?
If he's like you, it's difficult.
Because this is 1 over. That's in the denominator. This is my g function, right here. That's g, and it's divided by this. So divided by 2 is like multiplying by 1/2, right? Oh, that is so cool. So basically, can we do that with any 2 functions? Yeah, that's pretty cool. All right, onward and upward. 2.13, part 1. If we have time, we might come back and do some extra stuff. We're getting short on time. So 2.13, part 1. At the top of the page is all the same properties that you put in the notes yesterday. So I'm not gonna go through all that, we already talked about all that. Let's skip straight down to example 1. This is easy. We've already done some like this earlier in the year. How am I gonna solve this problem? I don't know, how am I gonna do it?
Add the 2 over.
Add the 2 over, absolutely.
Change it from exponential to logarithm.
Okay, so what would that look like, Kennedy?
Log base 4 9.
I hadn't thought about doing that, but is that right? That's fine. And then what would you do, Kennedy?
Put it in the calculator to figure it out.
Well, be careful, it says leave your answer in exact form. So what would we put into our calculator here?
Log of 9 over log of 4.
Bingo. That is exactly right. That is exactly right. Now, this is perfect. You might, what I was thinking about doing was taking the log of both sides here, pulling the exponent off. But I get exactly the same thing Kennedy got. So it doesn't make any difference which way, whatever makes sense to you. That's exactly right, right there. Exact form means don't type that in because you'll have to round it off. Beautiful. Okay, let's try the next one. All right, what do you think we ought to do with this one?
Move the 5 over
Move
log
the
of
5 over. Okay, so one option, my own particular style is, I'm gonna log both sides. Now Kennedy might convert that into a logarithm form, up to her, up to you, completely, doesn't make any difference. If I take the log of both sides, then the exponent comes out in front, plus logarithms are so beautiful. That is the coolest thing ever. Getting that exponent down here is so great. Then what?
Divide by log 2.
Divide by log 2. And finally, subtracting 3. If we had a if we were supposed to be using a calculator, isn't this what we would type in? But since we're told to leave it exact, we'll just stop right there. So if this is a no calculator question, this is where we stop. All right, try that last one, or C. Try C with your partner. See what you guys can come up with. Did you guys all eat quiet pills for lunch? You're also quiet today. Or have I managed to hopelessly bore you in 20 minutes? All right, let's hear some groups. Anybody come up with something yet, Raina?
First side, my
Oh,
sister.
no, go ahead. Yep, go ahead.
I added or subtracted the 3,
Okay.
and then divided both sides by the negative. So they were,
So you got 5 halves.
or, yeah. And then I did ln to both sides. And
That is exactly perfect. Couldn't be any better. You okay with that? Good deal, Joe Funk. Awesome. All right, let's turn the page. Now we're gonna do the same thing, but we're doing it with logarithmic equations. These were all exponentials. Now we're solving logarithmic equations, leaving our answers in exact form. All right, so what would you, just normal problem solving, what would we do first? Subtract the 4, yep.
ln.
And then,
Divide by 2.
yep. And now we're kind of stuck in terms of, adding, multiplying, whatever. But what can we do? Log roll it, not log both sides. Change it into logarithmic form, what I call log rolling it. So 3 to the 3rd is x plus 3. This is how we change from a logarithm into an exponent. So 27 equals x plus 3. This time I get a nice round answer. Did you get 24? Perfect. All right, try the last 2. Let's see if those work out as nicely. Honey, you need to go to the nurse or something?
Yeah.
Okay. I knew it was exciting, I didn't know it was that exciting. Lily, you guys got these done?
I have a B, but I figure out.
Okay, but we got B?
Yeah.
What did you do with B?
So first I subtracted the 2.
Yep.
That's in front.
Okay,
Then I log rolled it. So I got 5 squared equals 2x minus 1. And then 25 equals 2x minus 1. And I added the 1. And then divided it by 2 to get 13.
beautiful. Beautiful. Everybody okay with that? Now, she said she had a little concern about this one. Did anybody make any progress with this one? Well, you knew how to start it. What did you do to start it? Multiply by 5. Now, we're gonna log roll this. Julia?
Isn't ln is just log base e?
It
so we
is.
just turn it into e to the 5th is equal to 2.
Yes, ma'am, that's exactly what you're gonna do. So e to the 5th equals 2 minus x. We are not concerned about having e in our answer. E is a constant, just like pi. It's okay to have e in your answer. So then what?
And then you would move the 2 over.
So e to the 5th minus 2 equals negative x.
And negative e.
So x equals 2 minus e to the 5th?
Yep.
That is exactly right, Julie, nice work. So if you were perplexed by that, you got it now?
So we just like wouldn't solve it all the way, like remember?
Well, remember, when we're solving for x. So the key is to have x equals. So when you have that, you're considered solved. This is not a variable. This is it would be like having an answer like 3 plus pi. That is solved. I mean, that's as far as I can go unless I'm supposed to type it on my calculator and get some decimal. Okay? So this is this is the perfect answer because there's no round off there in it. Okay? All right, that's exact form. That's what those directions mean. All right, anybody else about this? All right, down to example 3. Now, the situation in example 3 is we have logarithmic equations, but they have more than one logarithm in them. Okay, so these ones we just solved had one logarithm. And so every time we kind of move things around and then log rolled. That's what we did. We are not going to do that in this problem. There is a rule in our subject that you cannot solve a logarithmic equation if it has more than one logarithm on the side. So as long as it only has one logarithm, I can do it. We did it. There it is. Perfect. If it has 2 logarithms on the same side, you have to put them together. So step 1 is going to be to put these 2, they're on the same side of the equation. They have got to be put together. Now think about your properties. How are they going together? As a multiplication. What's getting multiplied? The 3 and the x plus 4. So this is going to be 3x plus 12. That has to be step 1. Don't try anything else, you'll be wrong. Now, Our other problems had one logarithm equal to a number. So we log roll. E to the 5th is 2 minus x. That is not our situation here. Think about it, use your common sense, logic. If the log of this hand equals the log of this hand, what has to be true about these?
You should raise the law.
They gotta be equal, yep. They have to be equal. We're not, you can't divide by LOG. That means nothing. We're not canceling out the LOGs. We're simply saying that the only way log M can equal log N is if M equals N. So that's what's happening. Then we just solve it. So what we got? 2x equal to 14. Did you get x equals 7? Now it's time to talk about the possibility of extraneous roots. This is not extraneous. But had my problem been, instead of x plus 4, had it been x minus 10, I would have done everything the same. Of course, the answer would be different. But let's suppose that was the original problem. If I put 7 into both of my parentheses, did you make it to the nurse?
Yeah.
If I put 7 into both of my parentheses, this side would be log 33, but this side would be log what? Negative 3? Can you take the logarithm of a negative number? We talked about that. What do we know about log x? What's the domain? What does x have to be? It has to be bigger than 0. So whatever you end up logging must be positive. So if that had been my problem, then this would be an extraneous root. Because when I put it back in, I had to take the log of a negative, and that's not allowed. Now, that isn't what I had to start with, so 7 is fine, but for the rest of these problems, be on the lookout for some extraneous solutions. All right, so go ahead, give them a shot, B, C, and D. Let's see what you can come up with. Every single one of them has more than one logarithm on the side, so you want to do your combining first. You have to combine your logarithms first. my stab at them up here. Let's talk about these. If anything doesn't match, you let me know. Oscar, you got all done?
Yeah.
That didn't sound convincing. Do you match me on all of them? I got 9/5 for the first one. I got 5 for the second one, because -4 would make this negative, right, well, make both of them negative actually. So I threw it out. And then I got 3e squared for that last one. So that last one I had to log roll because it only had logarithms on one side. I know I don't need to tell you this, but when we got rid of these logarithms right here and right here, when we got rid of those, that can only happen when it's log equals log. You can't look at the original problem and say, oh, they're all LNs. I think I'll just erase all those. That doesn't work. You have to have log equal to log. So you have to do that combining step first. Okay? Perfect. All right, that was example 3. Okay, I'm not sure. Go ahead and do example 4. I'm not sure what's different about that. They look the same to me. I see one thing that's a little different, I guess. What are you doing with those coefficients out in front?
Turning this off.
Making them exponents, yep. You're making them exponents. I put down my first step for both of these. Anybody solve the first one there? What did you get for problem A? No solution, because what did you come up with? -8? Can x, look at the original problem, can x be -8? No, that's why you canceled it out. What'd you get for this one? -7/6, he says, which is another no solution, because if you put -7/6 in the original problem, you're taking a log of a negative. One more caution, only because, years and years and years of experience. Negative answers, so when it says x equals negative, that should always make you pause a second. But is the fact that the x is negative, is that what makes it extraneous? No. What makes it extraneous is when you put it back into the problem, you're doing log of a negative. So that -8 would be fine if the original had looked like this. Because if you put -8 into that, you're still good. Similarly, positive x's can be extraneous. Because let's say we got +8, but if the original problem was x minus 10, then +8 would be extraneous. Do you see what I'm saying? Always look at what happens when you put it back into the problem. All right, life is good. Number 5, or example 5, looks so complicated, so hard, but it isn't. What are we gonna do with number 5, example 5? Find all the values of x where the graphs of f and g intersect. Now, we're not talking about literally graphing them. When they intersect, doesn't that mean they're equal? So we're just solving the equation ln x plus 10 minus ln x has to equal ln x plus 3. Now, could we solve it graphically? Sure, but this is so much faster. Does everybody follow what's happening here? We're just setting them equal, because that's where they're going to intersect. Combine. What can we do now? Well, we're going to get rid of the ln's. We don't need those anymore. Multiply the x, right, Bryce? Now that's going to give me a little quadratic. So I'm going to want to get it equal to 0. With any luck, that will factor. What if it didn't factor? We're going to run into one soon that doesn't, so we need to use the quadratic formula. It's no big deal. That doesn't factor. Shoot! Ha! Well, guess what? I thought it did, but I was thinking that 3 stayed, but that's a 2. Oh boy! So guess what? Quadratic formula. Here we go. B plus or minus the square root of b squared minus 4ac over 2a. What's under there? 40. Which is 2 to 11. So -1 plus or minus root 11. On algebra. 2 right there. Does that look okay to everybody? Now I need to go back and look at my original problem. Right here I'm taking ln x. So that means I better be positive. So what about -1 plus the square root of 11? Is that positive? Yep. What about -1 minus the square root of 11? Nope. So our answer is -1 plus root 11. All right. Number 6 is exactly the same thing. Try that one on your own. What are the x coordinates of the points of intersection? It's just like this one. I think that one does factor. Or is that just wishful thinking on my part? It does, good. What'd you get for your answers, Raina?
I got 7 Fs.
You also got -2, but you threw that one out. Anybody need help with that? Did we all get that? Did we all multiply the 2x minus 3 and the x plus 4? So that's where the quadratic came in. Quinn, you following along? We're plowing today. Gotta really keep on your toes. All right, example 7, here we go. These are just like the ones we looked at earlier, except we have the exponential on both sides, which actually makes the problem easier, I think, because if 2 to the 5x minus 1 equals 2 to the 2x plus 7, can't we just skip the 2's and set the exponents equal to each other? Doesn't that make sense? I got 8/3. That problem was set up perfectly. Problem B is not quite as perfect. What are we gonna have to do first with problem B?
Same base.
Get the same base. And what base are we gonna choose? 2. 2. We had a question like this on one of our quizzes, and somebody was trying to go up. Never go up with your base. Bring it down. So leave the 2. I'm not saying you can't go up, but it makes it so much harder. 8 is 2 cubed. Now what happens with these? This is a double exponent. We have the cube, and then we have the original 2x minus 2. What do we do with those? Distribute them, multiply them. Yep, so 9x minus 6 is x plus 5. Did you get 11/8? By the way, it didn't happen here, but can x be negative? It's not, but could x be negative in a problem like this? Yes, because x is the exponent, and in an exponential, guys, what's the domain? What's the domain? What are the x's in an exponential? All reals, right? So anything goes with exponents. It's only logarithms that we have to worry about our domain. All right, do the last 2. And come on up, if you think you got one of them, would you come out and show your work and do your problem for us? And I need to move both of them down.
Which one are you doing, Gary?
Is that, oh, that's this one. I might have you way out. There you go. They're gonna do them. Did you already do them?
One more.
You are not on vacation. By the way, seniors, please remember your presents for the little kids on Friday. Don't let your little kid be the only one without a present. That would be terrible. those are the answers that I got. What do you think? Everybody okay with the 6? The green might be kind of hard to read. She got -1 as her answer. She chose 1/2 as her base. So she left this one and changed 4 into 1/2 to the -2nd. Is that the same as 4? Yep. When I did this, I changed them both into 2s. She chose to change them both into 1/2s, which is absolutely fine. And our answers came out to be the same. Any issues? Alright, I'm gonna stop there. Your 212 homework will be due, I guess, on Monday. 212 is due on Monday. And you can get your phones and get settled back in your seat. Get ready to